course we are treating for today is CHM 416, which is organic synthesis. Still on the course, and we are going to be on what we call the module 1, unit 3, which has to do with transformation of alcohol to carboxylic. Yes, transformation of alcohol to carboxylic. That is the unit we are going to be discussing about today. And with respect to that, we have various forms of equation we have to discuss about here right now. So we are going to start from the oxidation of primary alcohol. Oxidation of primary alcohol. So now let us begin from here and see exactly what we got. Now, from what we have here, when we're talking about what we call oxidation of primary alcohol, oxidation of primary alcohol. So for the oxidation of primary alcohol, a sample of primary alcohol, we have ethanol, for example, which has CH3, then we have C, we have OH, we have H and HN. So oxidation will be able to take place here because of the tendency of the H and H present in this place to be replaced. So they can be replaced in that process of what's called oxidation using suitable oxidizing agent or oxidative agent, so you can get the needed product of what's called the carboxylic group. Now, with respect to that, we are going to start from here. The primary alcohol can be oxidized to either aldehyde or further to what we call carboxylic acid, depending on the reaction condition. Now, so the reaction condition is the most important things to know about here. So is it that you are converting primary alcohol to aldehyde, or you are converting it to what we call carboxylic acid? Okay, so primary alcohol can be converted to aldehyde in the presence of what we call the chromium. So primary alcohol, this is 1 degree, showcasing the presence of what we call one alkyl group per carbon atom, one alkyl group per carbon atom. So when we have primary alcohol, the primary alcohol being converted to what we call the aldehyde. This is done in the presence of what we call the Cr, which is what we call chromium. Okay, so together with what we call H2O is produced, then the next compound that will be formed here is what we call the aldehyde hydrate. So these aldehyde hydrates can then be converted to what we call the carboxylic acid as last products there. Now, this is the process involving what we call complete oxidation. At first, where you have what we call the ROH being converted to what we call the RCHO, and being eventually converted to what we call the RCOOH. So that is exactly what we have there. Now, we're giving one typical example in this place that we have to check carefully. One of the examples given here is the conversion of what we call the 1-butanol. We can convert what we call 1-butanol to what we call butanol. Take note of that. Butanol. So in this place, there is formation of what we call the aldehyde here, and it is very, very important to distillate the process of the mixture involved, and it produces about 50% of this butanol that we have here. Now, number 2 that I have here right now has to do with using what we call the PCC that we've discussed about, and we also have what's called the PDC as well. So the diachromate, take note of that. So we can also utilize them as what we call the oxidative agents. So from the past question, from the National Open University past questions, we have it that a question says you should list some what we call the oxidative agents. So among those oxidative agents, we've discussed about them before. We have the PDC, we have the PCC, we have the H2, Cr2O4, we have what we call the KMnO4, we have K2Cr2O7. Most of these listed compounds, they are typical oxidative agents. Okay, so the second one that we have there involved in using the PCC, or we make use of what we call the PDC. That's number 2 there. Using PCC or PDC as what we call the oxidative agent. So it allows the oxidation to stop on the intermediate aldehyde. So that means there is no further reaction. You know, one of the disadvantages of some oxidative agents is that after producing the aldehyde, they proceed and lead to formation of what we call carboxylic acid. Since we are only interested in producing the carbonyl group, which is the aldehyde, we need some typical oxidative agents that can help us to stop at exactly at what we call aldehyde without proceeding to formation of what we call the carboxylic acid. That is where these mentioned oxidative agents plays important role there. So, for example, now when we have CH3, where we have CH2, we have CH2, CH2 followed by OH, 1, 2, 3, 4. That's what we have in this place. This is 1-butanol. Then, in the presence of what we call the PCC, or we make use of what we call the PDC, take note of that. You can come across question on this. Then the product that will be formed there is we have CH3, CH2, CH2, CHO. So this is the 1-butanol. This is the butanol that we have there. This case can also be used to convert what we call the ethanol to what we call ethanol. So there we are going to have CH3, CH2OH in the presence of the PCC/the PDC as the suitable what's it called oxidative agent using CH2, Cl2 alongside. Then we have the production of CH3, CHO as the product needed. This is the ethanol. The ethanol. By this one here represent the ethanol. Okay, so that is that one there. So this one, for the second one, they are what we call the conversion of primary alkanol to what we call the aldehyde. I proceed to the next one that I have there, which has to do with number 3, oxidation of secondary alcohol. So remember is very, very important. For secondary alcohol, which is 2 degree, they have 2 alkyl group per carbon atom. So that is, we have C, we have R like this, we have OH there, we have H in this place. The H that we have in this place is the one that we want to typically replace there. Okay, so that is why we call them secondary alcohol. They have 2 alkyl group per carbon atom with 1 hydrogen and 1 hydroxyl. So with respect to that, they can also be converted to the needed compound. In this case, using what we call chromic acid, okay, for secondary alkanol, in the presence of 20% excess of Na2, Cr2O7, okay. So secondary alkanol, take note of that. Presence of what we call the Na2, Cr2O7, okay. So This is the chromic that we're talking about, chromic acid. Then it eventually, using H2SO4 alongside, then it yields